Hi everyone, my name is John French. I teach on the software development programs in the Department of Computer Science and Applied Physics in the School of Science and Computing. I'm particularly interested in how we can use cloud-based platforms to enhance learner experience and the efficiency of what we do as lecturers in computer science education. So to that end, around this time last year, I happened to see on social media a customer success story that Microsoft Ireland published with their colleagues in Sligo, where they'd used a relatively new Microsoft platform called Azure Lab Services in teaching computer science in Sligo. And I thought, this is a bandwagon I need to get on. So myself and my colleague Daniel Cregg, we ran a pilot scheme in the first semester of this academic year, where we used Azure Lab Services across three modules on a couple of different programs in the department. So what I'm going to talk about today is I'll give you a short background on what the problem is we're trying to solve, where the pain points are that we're trying to address here, how this product, Azure Lab Services, solves those problems, and briefly describe our pilot scheme and the results that we had with it. So a little bit of background then. When students are doing practical work in software development, they need to use, or when professionals are building software applications, they need to use what we call a development environment. So first of all, obviously they need a computer, but on that computer they're going to need a number of different tools. Typically an editor, what we call an IDE or an integrated development environment, which allows a developer or a student to write code. They're going to need a software development kit to actually run and compile that code. As students progress and work on more sophisticated projects and labs, they're often going to be using other additional frameworks and libraries, and then there will also be supporting tools for things like version control, package management, and all terminals, all different kinds of supporting tools. So there's lots of moving parts really in a development environment, and managing a development environment can be challenging. So how we typically provide these to our students is we have our lab machines on campus, and we set up development environments on these for all the various modules in our programs. And there's a lot of challenges with this. They can be difficult to maintain. So we have two undergraduate programs in the department, so each of those modules in those programs is going to have its own requirements for a development environment. So there's a lot of work involved for the IT technical staff and our technical staff in the School of Science and Computing in not only managing the physical machines, the operating system, the networking, all of that stuff, but then another layer on top of that, managing the development environments. So it's very labor intensive. And as a result of that, there's not a lot of flexibility really. There can be a lot of lead time in making changes or getting things set up in advance because it's so laborious. So you lose a lot of flexibility. And then there's an issue with portability. Students come in, these students are here working on campus in a lab session. If they want to go home and continue working on that or work on their project work, they're going to have to replicate that development environment on their own machines. And there's a lot of opportunities there to make mistakes, and there will always be some students who will take those opportunities. So what you end up with sometimes is students who they can't get something working, or they've had an error with something, and you get an email with a screenshot of some error message, and you don't have any visibility of what they've done. You don't have any visibility on how they've set the machine up or how they're running their code. So you're basically trying to pin the tail on the donkey, really. It's not an effective way to provide help to your students. So I'm interested in looking at how can we do this in the cloud then. So there's potential opportunities for providing development environments in the cloud. You get ease of access for students. They can continue to work on things at home and in our on-campus labs. And potentially there's also opportunities for staff to be able to actually have a look around in the student's environment and be able to provide more effective help. So there's a lot of providers are doing things in this space. There's the big three cloud providers, Amazon, Google, and Azure. They provide virtual machines and have various offerings in the educational space to various degrees of sophistication. And their offerings typically tend to be just a virtual machine. And then you configure that and set it up whatever way you want and give it to your students. Another category of offering is a virtual machine plus an editor. This is a relatively new kind of offering that is mainly industry focused, but has an education aspect as well. Things like Gitpod and code spaces from Microsoft and GitHub. These provide basically an IDE, an editor in a browser, which is backed by a virtual machine. And then we have another category of platforms which are a full platform. You have a virtual machine, an editor, plus additional tools like auto-grading and authoring and stuff like that. Things like Codio and Replit take this approach. So there's a lot of different ways to skin this cat, basically. The Azure Lab Services approach, this is a product that Microsoft have built. So Azure is Microsoft's cloud platform. It's their equivalent of AWS or Google Cloud, and it's widely used in industry. Azure Lab Services is a product that they've built on top of Azure, which is very much educational focused. So it is designed to allow you to provide virtual machines configured in a specific way to a group of people for a specific purpose, like a lab. It's a general purpose solution, so it's easily adaptable to whatever your particular environment you want to use. So this made it very attractive. And also, we have an existing relationship in the Institute with Microsoft. So this simplified the procurement and the billing. Also, security aspects. There wasn't a whole aspect of having to approve this new third party for processing student information. There's an existing relationship. We already use Azure in computing services. So we worked closely at the start with computing services to set up a billing structure so that we could identify the Azure resource usages associated with our department and bill that accordingly. And once that initial setup was done, basically it became our own responsibility then, and we could build our machines whatever way we want, roll them out to students whatever way we wanted. So this flexibility and this control was very attractive. So the pilot scheme then we ran, so this was in the autumn semester, the winter semester of the academic year just gone. So myself and Daniel Cregg used it on three different modules. So I used it in my distributed systems module. This is in 4th year of the BSc in computing and software development. So there'd be fairly heavy computing and coding elements to that module. And Daniel used it in his object-oriented computing 1 and 2 across 2nd and 3rd year on the BSc in computing and digital media. So this is an earlier stage and focusing more on fundamentals. So different computing requirements across the two programs that we use this on. Just to give you an example of the development environment for the distributed systems module, these are all the bits and pieces that I installed and configured and worked together to distribute to students. It doesn't really matter what all of these things are, and the point isn't to say, look at how fancy and sophisticated it is. It's not. This would be very typical of what a professional developer would be using to work on a real project. But by using a cloud environment that I can configure myself, I can get these things working the way I expect them to work all together. And this isn't really scalable, I think, to an on-campus lab. It would be very, very challenging to try to do this in an on-campus physical lab. So the workflow then for using Azure Lab Services. So you start off by creating a lab, and the concept of a lab in Azure Lab Services is basically a collection of virtual machines and users for a specific purpose using the same configuration. There is a Teams integration, so I'm showing some screenshots here of the Teams integration with Azure Lab Services. I'll explain in a minute why I use that. So the first step is you create your lab, you choose a virtual machine, so you're talking about the size of the virtual machine you're using, the power, the memory, and the number of cores, so how much power you need. We used the medium, which was like the second lowest, which provided perfectly adequate user experience, acceptable user experience, and not significant cost. The costs go up for more resource usage, obviously. And then you also choose an image. So the image then is the operating system, and there in the Azure marketplace there are lots of different images you can use, and there's also options for using images that have some pre-installed software. So we just used the simplest stripped down Windows 10 Pro. We wanted to use Linux, but for shutdown management issues that I won't go into right now, that wasn't an option at the time, but that's been resolved in recent versions of the service, so that is an option now. So once you've selected your virtual machine and your image, then there are various time management options. So this is billed on time. So you pay for the number of hours basically that each student's virtual machine is on. So you can manage that in various ways. You can set a quota for the year or for the term. You can also set a schedule so that, if you have specific on-campus lab times, that machines can only be used in that, or you can allocate time outside of that. And then there's also various settings you can use around auto shutdown. So the platform can pick up when the machine is idle or has been turned off, or students have disconnected, so that you don't have machines running in the background, consuming resources, consuming your budget without work actually being done. So it keeps it cost efficient. So to come back to the Teams integration, this provides really useful access management. So you want every student in your course to have their own unique individual virtual machine. So because here we have any student who registers with a module on Moodle automatically gets added to a team on Teams. We can use the Azure Lab Services Teams integration. If you create your lab inside this integration, then it will automatically create a virtual machine for every member of that team. So, only that student will have access to that virtual machine. So it provides a very streamlined way of access management and provisioning for every student in your class. So once you've created your initial lab, then you have a template virtual machine. It's not ready to roll out to students yet. So this is your opportunity to customize your development environment. You can install all the tools you need, play around with configurations, test if labs and projects work the way you expect them to do. And once that's done, then you can publish that template to the students, and the students are ready to work on it. The work that's been done in setting up that environment then can be saved, so you can publish that image to an image gallery in Azure, and you can reuse that. So here I'm using a template that I created for my distributed systems course, and I can reuse that next time I run this course, or I can also just use that as a starting point, make some changes, update versions of things, and I can do this a couple of weeks before my course starts. I don't have to have it done months in advance, and I don't have to be super organized because I'm not super organized. So once that's done, your image has been published, students are ready to start working. So students initially need to go in through Teams to get access to their machine, and this is the view they'll see. If they go into the Azure Lab Services integration here, they'll see a machine here, and they can manage the machine here, as in start it and stop it. So they need to go in here, they'll be assigned a machine, and then after that they can go in through the Teams integration or through the browser at just labs.azure.com. And they will, whatever way they get in there, they will see their virtual machine for your class. If they're in multiple modules that are using lab services, they'll have a unique virtual machine for each of those. And the authentication here, it's all through the same Microsoft Office 365 that they use to log into Moodle, Teams. So it's single sign-on across the whole system, which is really useful. So students manage their virtual machine, they turn it on and off here. Then to connect to it, they connect via remote desktop. This is a tool that's installed by default on Windows, and there's clients for Mac and Linux. So they just remote into their machine, and then they can use it full screen as if they were working on their own local machine. And another advantage of this is basically you don't have students if students are using different operating systems, you'll always have students in the class who have Windows, Mac and Linux, and you don't have these cross-platform problems trying to provide different versions of different things. Everyone's using the same machine, and they can all access it no matter what operating system they're using. So the usage and the costs then. So here's the three modules, my distributed systems module and Daniel's object-oriented computing 1 and 2. I have 45 students in my module who used up about, on average, 32 hours of compute time. So this is the time that the virtual machine was on over the course of the lab in this semester. And the cost came out at roughly about €11 per student. There was a big variation in the time the students used, as you might expect, but and you get a good view of engagement as well. And then over Daniel's 2 courses, he had about 25 to 23 students, different computing requirements there, but you can see that it was coming out, costs were typically for about 25 to 30 hours. You're talking roughly €10 per student for the term. So for what we got out of it, we found it very cost efficient. So some of the benefits then, it was really portable. So students could come in, work in an on-campus lab, and then just turn off the machine and go home and resume exactly where they left off on their laptop, on their desktop, on the bus, with a hotspot, whatever. It was entirely portable and with the same environment. It completely eliminated student setup issues. So any questions I got were like real questions, as opposed to, I can't get this working, I did this wrong, I can't fix this, it's not working on my machine. It just completely eliminated a really common category of problems students have. So when students did have problems, something, they were confused about something, or maybe they'd made some error in the coding, I could help them effectively. So it was very easy for me, and we did it both in the lab and remotely at home. I can just fire up the student's machine, they have a problem, I can start up their machine, go in, have a poke around, see what they've done, actually run their code, which is the only real effective way to fix code, is to actually run it and see what's happening. So I could much more effectively help them solve their problems. If they're going to take the time to contact you and you're going to take the time to respond, you both want to get a good resolution out of it. And that's what it allowed us to do. An additional benefit was it helped us track engagement as well. So you can see week on week the hours per each student, how many times their machine has been on and they've been using it. So you can really see who's putting in a lot of work and who needs a reminder to engage. And we found the cost, as I mentioned already, we found it very cost efficient. Some of the drawbacks, some of the students mentioned that the startup times could be a little bit slow, and initially creating the lab was a little bit slow. I mean, maybe we're talking an hour and a half to create a lab. And starting the individual machines could take a few minutes. But we had a meeting with the product manager with Microsoft in Seattle in the spring, and looking for feedback, and we mentioned a lot of these things. So a lot of other people have as well. So in a recent update, a lot of these things have been improved. So they're continuing to build out this platform and improve these issues. Some students mentioned that if they're at home in rural areas where they don't have fast broadband, they had issues connecting. So it does require not super fast broadband, but you are going to need a decent network connection. So those students possibly may need to be supported to set up an environment on their own machines. But it was a pretty small minority had that issue, and I'm not really sure how to address that, but we'll see. We asked our students then how they found their experience of using lab services, and it was overwhelmingly positive. With about 40 respondents in my course, 92% said positive or very positive. And the neutrals were mainly people who complained about the startup times or the connection speeds. And a snapshot of some of the comments. So it was really nice to see that students fed back in their comments unprompted that it helped them solve the problems that we were aiming to solve. So the things like I didn't have to mess about with my own computer to get the environments working, could be accessed from anywhere, everyone has the same machine to work with, and so there was a lot of really positive feedback. So as a result of this then, we've continued with it in our own teaching, and a lot of our colleagues in the department have started trialling it as well in their own modules. So there's, I'm not sure exact numbers, but there's a good few of our colleagues are using this now. So just some acknowledgements then. My colleague Daniel Cregg, he's a real early adopter, and he powered ahead with his usual energy and ironed out a lot of glitches, so it really helped him to make this a success. He couldn't be here today, unfortunately. Our former head of department, our outgoing head of department, Sean Dignan, was really supportive with, as always, with providing the budget and setting up the logistics. So thanks a lot to Sean. And we worked very closely with computing services. We couldn't have really have done this without the support of computing services. Donald McGinty and his team, particularly Shane Feeney, were really helpful in that. So that's it. Thanks a lot.
Now, questions for John? Thanks a million. And there is a. Oh, there is. Great. Thanks, Meg.
A question.
You go back up here.
Do you see applications further down where students might use it in further modules so that what you're teaching in the virtual environment, they would go further into different modules and use the same platform?
The question is there opportunities for you continuing on and using this in other modules for students? Absolutely, yeah. I think the power of it is the flexibility. That it is. I showed kind of a sort of a taxonomy of cloud-based solutions to this, and some of them are very focused and directed. The usefulness of this really is that it is very, very, very general purpose. So, and it has already happened that students have used it in one module and then gone on to use it in another module. So it can be very much adapted to courses in programming at an advanced level or an introductory level, or even in things like digital media. There are images available with Adobe Creative Cloud. So I think it's suitable for anyone who has a computing requirement where it may be awkward in some way for students to set it up on their own machines. This is a potentially useful solution. Like that.
Thank you.
Thanks.
So we have a question online. John, did you allow 24/7 access for students, or did you time day restrict it?
Will I repeat the question? The question is, did I provide 24 access to students, or time? Did I restrict it by time and day? There was the option when I set up the lab to provide a schedule and only access through lab times. Though I chose not to do that, I just went with a block of time an estimated block of time for the term, and I discovered I wildly overestimated the amount of time students were going to spend working on it. But I noticed from commits in GitHub that students would work at all kinds of times. So you have the flexibility if you want to do that, but I think it suited students to just work anytime, 24/7. Okay, thanks a lot.
Great.
Okay.
I think it's a super idea, actually, as someone who's messed up system variables on my computer so many times trying to configure an environment. Quick question though is there interconnectivity between the machines for the students? So if they're pulling from GitHub, for instance, on a group project, or do they have network connectivity outside of the virtual machine when they're in it?
The question is there network connectivity outside of the virtual machine when they're in it? Absolutely, yeah.
So they can and pull GitHubs and projects.
Exactly. So the workflow that I would use is I'd get them to log into the machine and just treat that as their desktop, open the browser, go to Moodle there, click a link to accept an assignment, put it down from GitHub, push it back to GitHub from there. So it's basically just like a normal computer. Okay, thanks.
Great.
Thanks, William.
Thanks, John. Great work, and great work by the Department of Computing and Physics. I think maybe have a look out. There's funding coming through. If you need further funding, just based on Meg's idea, there might be opportunities to extend it into other modules, John. And we're hoping hopefully next week, releasing some details about another round of Teaching and Learning Innovation Fund. I know there was just a typo here. I know it wasn't directly supported by the National Forum. Your initiative was supported by the Department of Computing.